we have looked at what inductive force is, and we're going to look at now different ways of reasoning that build on inductive force, in which we need to check for inductive force. One type of inductive argument is an inductive inference, which should be specific to you. It's a type of generalization, you might say. And you could generalize from a general claim to a more specific claim, as for example, 60% of the staff for a political party from the Netherlands is that works at the UvA, like blonde hair. Bobette is a employee working at the University of Amsterdam, so Bonnet should be Bobette, likes blonde hair. So the conclusion is probably true, given that the premises are true. The point here is that this is a type of argument that you might learn to recognize. So here's somebody generalizing, taking a specific instance from a group that has a more general description and draws a conclusion about that specific individual. You can also go from a more specific description to a more general description, which is what you're most familiar with, right? Because that's what we do as psychologists, or as researchers, we take a sample and try to generalize to the population on the basis of that sample. And which brings me to the most important part that you need to check for. So if you encounter an inductive inference, any type of generalization, you need to check for, look out for the representativeness of the sample, right? So I'm not going to show you the actual video, or I could show you the video, but you wouldn't get the sound.
John here says that he prefers
this is the Pepsi challenge. This is an example of an old commercial, and it's a blind taste test of colas. And according to the commercial, John prefers brand number Y, and that turns out to be Pepsi and not any other brand. And then you get some information. In taste test across Australia, over 50% of people prefer the taste of Pepsi Cola over the leading cola. The question is, if somebody would give you this argument, or is this the intended argument, more than 50% of respondents in Australia found Pepsi tastier than any other brand, could you then conclude that Pepsi is tastier than any other brand? I hope you agree with me that that's not a forceful argument, right? Could somebody point out why that's not a forceful argument?
Because it's valid?
No, it's not.
Because the residents of Australia are just a part of the complete population, and of those people, only 50% preferred Pepsi. So to say that Pepsi is tastier than any other brand would be not forceful, because it's less than 50% of everyone.
Yeah. At the very least, I think you've both have good suggestions, right? So at the very least, there's a connection lacking between that premise and the conclusion. So more intuitively, you could say, why would this result from this sample in Australia allow me to say that one brand is tastier than another brand? So we need to specify when we can conclude that one thing tastes better than the other. And I mean, one assumption that makes sense is what you just made, that if something is tastier than another brand, it just is, then that would apply for all people. So we're talking about all people in the world, right? And the sample is just Australia, so that sample wouldn't apply to a conclusion about all people. You could even get statistical about it and look at what percentage of the world population lives in Australia, and then reason accordingly, but we're not going to go that distance. But you could even wonder whether, if we're just drawing, so Pepsi is tastier for Australians than any other brand, if that would have been the conclusion, would it then be forceful? I would still argue no, because we don't know whether this is a good sample, the way the sample was drawn from all Australians, whether it's representative for all Australians. So what we're talking about here is how representative a sample is to draw a conclusion. And in this case, if you want to conclude something to be the case on the basis of a specific premise that includes a sample, so you want to generalize from that sample to a broader conclusion, then you have to be specific about what the connection is between that specific sample and the conclusion. So we're missing some connecting premises here that would explicate why a taste test in Australian would have any implications for all people in Australia, let alone all people in the world. All right. So we looked at one type of inductive argument, inductive inferences. And we can also look at another type that you might encounter a lot in scientific literature. But I'm first going to give you a more silly example of an inductive analogy, which is also a type of generalization, you might say, right? Because we're sort of generalizing, if we can use the word that way, from a specific instance to another specific instance. So we're saying this process is the same as that process because they share a characteristic. So as in this example, in this cartoon from Calvin and Hobbes, in which he needs to hold a class presentation and says that just like snow melts, just like snow melts, students wither away when you bring them into the classroom. And this analogy builds on the following premises. So snowflakes are unique and exquisite. Children are unique and exquisite. Snowflakes use their uniqueness in the classroom because they melt. So children lose their uniqueness in the classroom. So this is an analogy. And if you're asked to assess an analogy, you would have to look at whether, well, the fact that they show some similarities, does it always also mean that they are similar in all regards that matter to draw this conclusion? And there are some general indicators you could use for assessing inductive analogies. So you could look at the quantity of commonalities. So if there are more similarities and fewer differences, all else being equal, you could say that the analogy that's being drawn is somewhat stronger than if there were fewer similarities. But beyond that, particularly the relevance and specifically the weight of those similarities are important. So is it relevant that both snowflakes and children are unique and exquisite for the conclusion that's being drawn? So or not? And what is the weight of the similarities and the differences that you found? So how predictive is it of having a certain characteristic for being something else? So the fact that you're unique, must that mean that you're like a snowflake in all other respects? If that's the case, then being unique is a very predictive property of for being a snowflake or being something that could melt in the or could lose their uniqueness in the classroom. So just to give you a better feel for using those criteria, you could also apply it to another example which you might have encountered in the past. So firearms are easily available, wanted, and dangerous for children. Kindersurprises, surprise eggs. I tend to forget what it's called in English, but it's a chocolate egg which contains something to play with, right? It's contained again in another plastic egg. And if you would bite that open, there's all sorts of small plasticky things in there that children could choke on. But those are available and wanted and dangerous as well for children because of the choking hazard. And those, for that reason, that a chocolate egg with a surprise in it is prohibited in the United States. And therefore firearms should also be banned in the United States, or therefore firearms are also banned in the United States. So you could change this from a descriptive to a prescriptive argument, right? So you could say Kindersurprises should be prohibited in the US, and then you could say firearms should be prohibited in the US. But for now, what's most important is that you see that this is an inductive analogy, right? Somebody tries to convince you that something is the case because of similarities between two examples, right? So firearms have certain characteristic. This toy / treat has certain characteristics, therefore they should be treated the same, or therefore the same applies to both examples. And again, you should wonder how important or how relevant are these similarities, right? So how important is it that the way in which a children's toy is wanted, is that similar to the way in which firearms are wanted, and the way in which children's toys are dangerous, is that similar, and indeed relevant, that similarity to the fact that firearms are dangerous as well. Finally, a final example, which you might return to in the next tutorial. I'm not sure whether that's still in the exercises. But this has been used in the debate among politicians about climate change, in which people say that, it's more of a slippery slope argument. We'll talk about that in a few lectures. And some politicians say that, yes, if you put any restrictions on CO2 emissions, that also means that you put restrictions on breathing by human beings, right? So to put that in stark relief, you might say that the following argument is behind that. So people emit CO2, cars emit CO2, so people are cars. It would be really, it's a bit of a ridiculous simplification, of course. But of course, you can't assume that people are like cars or similar to cars because they share one characteristic, the emission of CO2. So you can't also assume that if we're going to ban cars, you're also banning breathing by human beings, right? So again, you should wonder, using the quantity, relevance, and weight characteristics, how strong of a comparison is this? So how strong of an analogy is this? Or am I dealing with a weak analogy? Which is one of the fallacies we're going to talk about next week. So finally, before the break, yes, I think this is the last thing before the break. You can look out for inductive analogies in scientific publications as well. So there's one article which you're going to read in more detail in the next block, on which some of you are going to do that presentation, right, which is part of the grade. The Pecha-Kucha presentation. It's about the link between psychological warmth and physical warmth. And the idea is that cold is something you can experience when you go outside and it's not sunny and you feel cold on your skin, right? That's a physical sensation of cold, but you can also be cold as a person, and that's more intended like a psychological characteristic. Do you experience warmth? Do you feel warm and fuzzy, or are you very cold in your expression and your delivery? And there's some researchers that they've done research on that, and indeed they think that the two are related or similar, perhaps the same. So what is similar and the same is perhaps the sensation of physical warmth and the psychological experience of warmth. And they argue that they might be the same or directly connected because indeed recent research on the neurobiology of attachment has added further support for the proposed link between tactile temperature sensation, physical warmth, and feelings of psychological warmth and trust. This research has revealed that the insular cortex is implicated in processing both the physical and the psychological versions of warmth information. I hope that by now you should be able to see that this is an inductive analogy as well, right? They're saying, well, here we have two things, A and B, physical warmth, psychological warmth, and they share a characteristic. They're both related to brain activity in this area of the brain. So should we therefore treat them the same in all other respects? Well, on the basis of this information, we shouldn't. There's a lot of information lacking, and we should have more information about the relevance and the weight of these similarities for saying something about, before we conclude that actually the same process is taking place. Saying that it means that they are the same because they are both related or concurrently happening with activation in the insula is similar to saying that, it's a bit of you could call it a tabloid version of scientific inference, right? So if you would see a boat and as is indicated that, the animations aren't working, but behind this picture, there's a picture of, there he is, here's Brad Pitt, and there's a woman on the boat, right? And you would saying, well, Brad Pitt is on this boat, and there's a woman on this boat, so that must mean they, right? They're in a relationship, or what's happening here? You wouldn't find that you wouldn't find that convincing, I hope, right? Because just the fact that two people are on a boat together doesn't necessarily mean that they're the same person or they're involved in some way, right? So if I were to tell you that Peter Starreveld was spotted on boat X and Sharon Klinkenberg was spotted on boat X, you wouldn't say that Peter Starreveld and Sharon Klinkenberg are actually the same person, right? That's a weird way of reasoning. In the same way, we shouldn't conclude that physical warmth and psychological warmth are actually the same or have something going on together because they are spotted having the same they're involved in the same type of brain activity. It's like saying Brad Pitt and somebody else is spotted on a boat, or saying that Peter Starreveld and Sharon Klinkenberg are spotted on a boat. we still need to wonder how specific that match is, right? Or whether it's very general. So if every form of psychological activity would result in activity in the insula, then it's not really big news that these type of processes both lead to activation in the insula. Just like it wouldn't be big news if Sharon Klinkenberg and Peter Starreveld were spotted together on the ferry to Amsterdam North. But perhaps it would be bigger news if it was more specific that they were in the same boat and they were spotted together in a small rowing boat, right? That would be more interesting for the type of conclusions we could be able to draw. All right, the final type of example is the inference to the best explanation, which will return in the, or the authors will return to that in the 5th chapter. But I wanted to briefly point it out here because it's a common form of argumentation in scientific reasoning as well. So what we're doing is reasoning towards the best explanation. So for example, if we apply this to a Cluedo example, and you have found out that a specific weapon is the murder weapon, the candelabra is the murder weapon, then you can consider, given that this is the murder weapon, how likely is it that suspect X would be the murderer, or suspect Y would be the murderer, or suspect Z would be the murderer. This is what you should do when playing Cluedo, right? So I found the murder weapon, I found a couple of clues. Given this information, given this data, how likely is that to be true, or this to be true? And if the murder weapon makes it much more likely that the maid is the murderer, but it has no impact, or doesn't make it more likely that, I don't know, the gardener or the other Cluedo types are the murderer, then you have found evidence for the maid being the murderer. You don't know for certain that she's the murderer, but you have found some evidence that points in that direction. And that's also how I guess most scientists are trying to argue about their results. They're not saying this is necessarily truth, but they try to argue, well, this could be a good explanation for the fact that happened, right? So for this data, this murder weapon, but for this research data, this theory would be the best explanation. So they're reasoning to a conclusion that says this is the best explanation for what we found out. So they're arguing that I found a difference in P2, and that would be highly likely if our theory are true. They still have to show how specific that is, right? So how specific their prediction is, and perhaps you would expect that type of brain activity if any other theory were true as well. So that's not a very distinctive research result and not strong evidence for one theory over another. All right, so we looked at inductive force, and we looked at different types of inductive inferences, and we tried to gauge how strong those inferences are. And I tried to give you some hints for where you need to look out for when you encounter these type of inferences, and that might even be in scientific publications. Again, I didn't add those examples of scientific publications to make stuff even more complicated. I just wanted to point out to you or give you a sense that how the stuff about argumentation is related to scientific reasoning. And we're going to go into more detail into that in the second block of the course.